Hello everyone, welcome back to the channel. I hope you guys are doing amazing. So in today's daily challenge on Leetcode, I will show you two approaches to solve the problem, uh, starting from the brute force to the bit manipulation, but both will be of the order of time complexity log k. Okay, so let's see today's problem and try to solve it together. So we are given this question where Alice and Bob are playing a game. Initially, Alice has the string word A. You are given a positive integer K. You are also given an array operations where operations of I represents the type of operation. So there can be, it is a binary array. The operations of I might have 0 or 1. If it is has 0, then you need to append a copy of the word to itself and then generate a new string. And if the operations is something like 1, then you generate some string by uh, just incrementing all the letters of the string and then appending to it. So let's say you have something like ZB, then you will append AC to it because you increment Z, which will be A, you increment B, which will be C. So you get AC and you need to add that AC to the word. So this is what is meant by operations of 1. So what you need to do is return the value of the kth character in word after performing all the operations. You can also note that the character Z can be changed to A. So it's trivial. It's trivial. So if you have solved yesterday's problem, it could also be solved by brute force approach. But since here K is 1E14, you cannot construct a string of length that long because that will definitely give a TLE. So there is no use of discussing the brute force solution. You can always do that. Uh, so let's try to check two methods. Let's try to check two methods. So first we will understand what is exactly going on. First we will try to take some cases and try to understand what is exactly going on. So initially we have the string A, right? Let's say we perform an operation of the type 1 in which we change A to B and make it AB. Okay. Then again, I try perform an operation of type 0 now. Okay. So in which I do something like AB. Okay. In type 0, what it was told, you append the whole string to itself. So you just append it. Then I perform an operation of type 1 in which I do change all the elements. I increment all the elements to BC, and then append this BC to this. So it becomes AB. Okay. It just becomes AB, and then again for BC. Okay. So what will happen now? What will happen now is that I try to perform another operation of the type 1, again of the type 1, and this time I change all the characters again to something like this and this, and I append whole of this string to this. Okay, so what you get in return is that you will get something like this BC, and append this whole string to this. I hope you understand this. I hope you understand this, right? And then again, if you try to do something like 0, if you try to do something like 0, you will get something like this whole string you will get. And I mean, the whole string you will be repeated 2 times, right? I hope you understand what we need to do exactly. So I will just show you some examples. That is why I'm just writing this again, A, B, and so on. Okay. So this has a total length of 1. This has a total length of 2. This is 4. This is 8. This is 16. So you can see it is doubling every time, right? It's doubling every time. And I will take 3 cases. Okay. I will take 3 cases. So this is the first half of the string. This is the first half of this string is ending here. So this is 16. So I will take something for k equal to 18. I will take for k equals to 16. I will take for k equals to 14. I will analyze all of these results and check what is my answer for each one of them. So you see, if you are given something like k equals to 14, what will you do? You will see, you need to return d because it's d written here. Okay. So how is that d coming? You try to trace that d. Okay. So you try to trace it. So if you see, if it is present in the first half of the string, it does not change anything. it does not change anything. So if it is present in the first half, as you can see, this D is given by this value, so it does not change, of course. And now you see, now in this string it is present in the second half, right? It is present in the second half, and the operations is also 1, so it gets changed to C. So this D was given by this C. Are you understanding this? Because this whole thing we changed to this, right? This whole thing we changed to this and then append this. So this D is given, this D is nothing but this D, and this is given by this C. I changed this to this, okay? And now I hope you understand that this C is given by this B, okay? You are appending AB to BC, and then this B is given by this B again. If it is operation 0, if it is operation 0, and first of all, this is in the first half of the string, so you don't need to do anything. This B is given by simply this B. It is present in the first half of the string, and then again operations is 1, so it gets changed to this. Okay, so what observations do you get? What observations do you get? I will write some observations. The first observation is that if while tracing, what are the observations? If character is present in first half of the string, is present in first half of the string, you don't change anything. Don't change anything, okay? Because that is not incrementing. That is not just incrementing, because you see D, if it is present in the first half, it remains D in the previous string also, because in the second half are only the changed characters only if the operations is 1. Okay. Now another thing you try to observe. Now you try to observe for something like k equals to 16. Okay. Now if k equals to 16, you see this D is again in the first half, so no use for that. No use for that. Now this D is in the second half, and it is taken from this C. This C comes from this B, okay, and this B again comes from nothing but this B and this A. Okay, so what you see, this is in the second half. This is in the first half, so it does not change. Then it was in the second half of this whole string, so it changes to C. Then it changes to B. But now you notice that although it is present in the second half, it still remains B. What is the reason for this? This is because the operation is 0. Operations is 0. So for operation 0, anyways, the character will not change and it will get to A. So every string, everything, if you trace back every character, it starts from A. It changes in some places, it changes in some places, and it does not change in some places. So for instance, this was like A, B, B, C, and D, and D. So you see, in some places it got changed. In some places like B to C, or A to B, or C to D, it got changed, but to B to B or D to D, it is not changing, right? So the second observation which you can tell, first observation was that string is present in first half, character is present in first half of the string, don't change. So you see, the second observation is nothing but if character is present in second half, change only if operations is 1. Change only if operations is 1. Okay. So only you need to count the number of changes. Okay, you just need to count the number of changes. So how many changes did happen here? You can see this is one change, this is one change, this is one change. So there were 3 changes in total. You just count the number of changes and you add that count to A plus 3. A plus 3 is nothing but D, right? Because it gets shifts from A to 3 times, which makes it D. So D will be your final answer. So I hope you understand this. Now, how do we implement this? Is quite simple. It's very simple, very easy. We just do something like, first of all, we see what is the maximum length which we should obtain, right? I mean to say that let's keep something length as 1. Initial length is 1, and you keep doubling it every time while you don't reach k. Okay, that takes log k time. So you just see how many times it happened. and you also need to see how many iterations it took place. So let's try to check that first, and then we trace back. We do it in brute force. Whatever methods I told you, this it will do the same thing. So let's see how to do it. You see, initially our length is nothing but 1. Okay, this will be in long because length can go to long. Length is nothing but 1, and the number of iterations, I will also count how many iterations I take to reach this. So the number of iterations is nothing but initially it's 0. So what you do now, while this length is less than this k, okay, you understand this length has to be just equal or greater. While length is just less than k, what do? You multiply length by 2 every time. In every step you are doing right? Okay, only. So you multiply your length by 2, and you increment your number of iterations by 1. So here you see that you find these many iterations and these many number of length. Okay, that is the length of the string. Now what you do? Now it's very simple. You just do something like while you decrement k. Okay, what you are doing here? K is 14. Now you are decrementing this, right? May or may not decrement, but let's say this 14, then it remains 14 here also. Okay, so let me see. This 14 is present here. Now this is also in the 14th place. Okay, now this is in the nothing but this, how which place it is? It is 6th place. Okay, 6th place. Then again it get reduced to 2nd place, then it again remains 2nd place, then it again goes to 1st place. Okay, so I need to reduce this k from 14 to k till 1. Okay, so I will just reduce this k from 14 to 1. So I will do while k is greater than 1. Okay, while k is greater than 1, I need to decrease k. Or may not decrease k. Okay, I will decrease k only if this is present in the second half. If it is present in the second half, I will always decrease k. So I do something like if k is present in the second half. So second, what do I mean when I say it is in the second half? So it is nothing but k is greater than ln by 2. If it is present in the second half, then what you do? You just decrement k. Uh, okay, so how many times you need to decrement k? You just need to decrement it power of 2 to the power this. Okay, 2 to the power of number of iterations. Uh, okay, number of iterations minus 1. So I will explain you this. And but the main thing which is there, which we need to put this first, is that the character is present in the second half, change only if operations is 1. So if the character is present in the second half, okay, uh, and the operations of this iteration is 1, okay, then what you do? You just increment your count. Okay, you just increment your count. Count is nothing but the number of times a gets changed. This is nothing but number of times a get changed. So you see, you just increment your count only then. Okay, otherwise you just move your k. And every time you should do one thing. You are understanding, right? This k we are subtracting. So what is the number of the iterations times I am subtracting? So if I am subtracting the iterations time. So this is like, let's say the iterations. I mean, this is the iteration 4, right? This is the iteration 3. Okay. Uh, so you see, this is nothing but actually iteration. This is, I just told one less. So it is something like this is iteration 5 and this is iteration 4. Okay. So subtract, how much I subtract? From 14, I subtract 6. So I subtract 2 to the power of 4 minus 1. I subtract 2 to the power 3, which is nothing but 8. Okay. So I subtracted 8 from 14. and I always subtract in powers of 2. I always subtract in powers of 2. That is by observation. You can also check that 6 gets changed to 2, which is nothing again but 2 to the power 2. Okay, so 6 minus 2 to the power 2 is nothing but 6 minus 4, which is nothing but 2. And this 2 we are getting from the iterations. Okay, that's why I do this change of it minus 1. That's why I just do this change of it minus 1. Okay, and you need to also remember that each time we are iterating from backwards, right? So each time iterations is getting decreased and the length value is also getting divided by 2. The length value is definitely getting divided by 2. Now you see operations of it, this also should be minus 1, okay? Because let's say you take something like this. So let's say you have something k equals to 10. Okay, you have some k equals to 10 and you have, I am taking this example from the example itself, is that 0, 1, 0, 1. Okay, it was nothing but 0, 1, 0, 1. Okay, so you see k equals to 10, so you keep iterating your it, the value of it gets changed from 1 to 2, 2 to 3, 3 to 4. Okay, so it settles down to 4 because this is nothing but 2, this is nothing but 4, this is nothing but 8, which is still less than 2, this is 16, which is greater than 4. So if you try to access these operations of it, you will get an index error, right? You meant the fourth element. You meant the fourth element. So you just access operations of it minus 1. So you just access operations of it minus 1. And that is all. That is all. And now what you do is simple. You just return. The count can be greater than 26 also, right? So you just need to do modulo 26 because z will get wrap around itself. After z, it wraps around to a. So your answer will be nothing but a plus this count modulo 26. Okay, this count modulo 26. If you try to run this code and we will check if there is any error or not. Okay, so it is actually giving some error. This is because this should be long, right? This should be long. One long, not just one. The left operator. You see, we have the accepted code. If we try to submit it and check, if we try to submit it and check, we also have an 100% runtime complexity. So now let us try to find something. Okay, let's try to find some more patterns. How we will solve this in a much shorter method using bit manipulation. So how we will actually solve this? So for the bit manipulation solution, you try to take something like k equals to 12. So this was 8 and this is 12. So k equals to 12. I just take it. Okay. So as I had told you already, for it can be traced back to always 1, right? It can be always traced back to 1. So for shifting of position from 1 to 12, how many shifts do you take? In every places there is some shifts happening, right? So how many number of shifts you take? So if you see, there are 11 shifts. Okay, there are exactly 11 shifts. So now so for k there have to be k minus 1 shifts. Okay, so this is nothing but the number of shifts. Okay, now for if you try to represent this count of shift in binary, this 11 can be written 1011 in base 2 in binary. Okay, so you see, and you see also our observations were something like these operations must also be 1 in order to increment our count. Okay, so what do you try to see here? What do you try to see from here? If you try to represent the operations in bits, it will be 1. First, you are performing this, you are backtracking it, right? You're backtracking it. So your first operation is 1, second operation is 1, third operation is 0, fourth operation is 1. Also, your shifts, you need 11 shifts in total. So you need shifts of something in this order, okay? In this order. So you see, if you try to see, operations must be 1, operations must be 1, and it must be present in the second half. So what does second half means? Second half also means that this bit is set in the shifting case. This bit is set in the shifting case. So this k minus 1, this k minus 1 shift, you see this bit is set. So actually this 11 is written in the form of 8 plus this 2 plus 1. Okay, this is nothing but 8, this is nothing but 2, this is nothing but 1, so it can be written in the form of this. Okay, and now this represents, it happens 8 shifts, somewhere it happens, somewhere there is 8 shifts, somewhere there is 2 shifts, somewhere there is 1 shift, and it then only cumulative of 11 shifts has happened. Okay, now uh, now there is shift only if there is shift. You also know that there is shift only if it is present in the second half. So these are nothing but present, this 0 denotes nothing but present in the first half. Okay, 0 denotes present in the first half, and this 1 denotes present in the second half. That is why the shift is happening. That is why this shift is happening. So if you try to see now, if you just try to check, this operation should be 1 and it must be present in the second half. Operations is 1 present in the second half. Okay, so what do you get from this? This, both of these bits should be set to high. The both of the bits should be set to high. So what do you mean by this? You just do an AND, right? So what you need to do, you just need to do operations and k minus 1. You just need to count the number of set bits in this, and that count is nothing but our this whole count, and you just need to return that count plus and the character A. You just need to count that plus character A. So how we will do that in bit manipulation? Let's see the coding portion. So you see how we are supposed to just code this out. You need to convert your whole operations array into a mask, right? So the operation array was nothing but 1101 in this case, and it's from the mask which you need to calculate. So if you try to see, I will create a long mask which will be nothing but 0. And if you know already how to calculate this mask, so I will just do it. This should be less than minimum of 63 comma ops dot size. So I hope you understand what I'm doing, because ops dot size can be up to 100, but you know that it cannot be more than 63. Making it more than 63 does not make any sense, because that is the number of that is the number of bits in long. Okay, so that's what actually. So I just create the mask of the whole operation. So I just do OR. I hope you know how to create a bit mask. You can just search it out otherwise. So you just do operations of I right shift I. Okay, so that is what. And I think you need to do a 1 LL multiplication also, because it might give you an error. So you shifting the ith bit by I, just shifting the ith bit by I and performing an OR in the mask. And what do you do in return? You do what is simple is that you just return answer plus A, and this built-in pop count, built-in pop count LL. See, built-in pop count LL is nothing but you just perform on k minus 1. You just perform an AND of k minus 1 with this mask, and just return it. Okay, just return it. So you see, I hope you did understand. This is nothing. This function calculates the number of set bits in k minus 1 and mask. So this mask, I told you why we need to do this and this operations and k minus 1, it just calculates, and we count the number of set bits in this using this operation and just return it. Uh, Add it to A and return it. So if we try to see, there is you can see a compiler error over here. It's no matching function. So it means that this need to be typecasted to integer value. If you try to see it now, so you see we have the accepted case. If you try to commit it, uh, you do get some wrong answer over here for this particular case only. So you see, I just forgot to do this modulo 26 because it wraps around itself also, right? You already know that it wraps around itself. So A after Z, it can be A. So number of count, we in the previous solution also we had done the number of count modulo 26. Now if you try to submit it, I guess it should work fine. I guess it should work fine completely. So yeah, it just works fine. The runtime is still 100% and our code is also much shorter now. So yeah, that was a hard problem for today. Marked hard tag and but I hope that was all for this solution and I hope your day goes much easier than the problem. Thank you so much.